Today's lecture is about the molecular orbital structure of ethyne. Ethyne, commonly also referred to as the acetylene, having the molecular formula of C2H2. And if we will consider the hybrid orbital structure or the molecular form of the ethyne, we can easily understand that carbon having triple bond with another carbon and it is attached with two of the hydrogen. So the structural formula C2H2 can be identified in such a way that carbon is attached with another carbon and each carbon is attached with the hydrogen, the single covalent bond with the carbon, and another carbon is attached with another hydrogen. And we are much aware that the carbon is a tetravalent in the organic chemistry, so 1, 2, 3 and 4. So in acetylene, we will consider each carbon as a central element and we will draw the electronic configuration. The ground state electronic configuration of the carbon 1s2, 2s2, 2p2. In excited state, that will be in which the electron from 2s orbital will jump to the 2p orbital. That will be 1s2, 2s, 2px, 2py, 2pz. Already here we are having the 2 electron 2p2 and the 1 electron will jump from 2s to 2pz. So in such a way that carbon having the 4 atomic orbitals that are half filled, 2s, 2px, 2py and 2pz. So as we already discussed or earlier I said that the carbon having the capability to undergo sp3, sp2, sp. So what type of the hybridization carbon will attain in acetylene or the ethyne? As we are much aware that ethyne is the first member of the alkyne family and that is also under the example of the unsaturated hydrocarbon which are having the triple bond. So the type of the hybridization will depend upon the number of the attachment. In acetylene, carbon will attach two elements and making two double bonds. So that is why it will give you sp hybridization. One s and the one p will combine to give you 2sp hybrid orbital, while 2py and 2pz will be unhybridized orbital, means they are not undergoing the hybridization process. As far as concerned with the sp hybridization, that is the particular type of the hybridization in which we will obtain two sp hybrid orbitals that arrange in the linear shape having bond angle 180 with two unhybridized p orbital, that is unhybridized py and unhybridized pz. So in sp hybridization, every element whenever it will undergo sp hybridization, it will contain linear shape with the angle of 180 degree with two sp hybrid orbital, sp hybrid orbital, sp hybrid orbital and the unhybridized py and pz. As far as concerned with the structure of the acetylene, each carbon will undergo sp hybridization. So here we can identify one carbon and 2py, 2pz. This is 2py, 2pz, sp hybridization, sp. In this structure, carbon is attached with another carbon which having the similar type of the characteristics, means it also will undergo the sp hybridization, making the linear shape. In such that each carbon is making sigma bond with another carbon. This is 2py, this is 2pz, sp hybrid orbital, sp. Here we can easily identify that there is end-to-end or head-to-head overlapping of the carbon. The sp hybrid orbital of the carbon overlap with another sp hybrid orbital of another carbon, making the sigma bond between carbon. This is the sigma bond between the carbon. Now if we will consider each carbon is attached with the hydrogen and hydrogen with the atomic number 1, 1s1. The spherical orbital will overlap with sp hybrid orbital of the carbon, making another sigma bond. The name of the overlapping in the sigma bond of the carbon hydrogen will be sps overlapping. While the name of the overlapping between carbon-carbon sigma bond sp overlapping. Now this carbon is attached with another hydrogen, and this hydrogen with s orbital will undergo the atomic overlapping, and as a result we will obtain the sigma bond, and the name of our overlapping will be ssp overlapping. Now in acetylene we are having 3 sigma bond, 1 2 3. This is sigma bond, this is sigma bond, this is sigma bond. Now the 2py unhybridized orbital will overlap above the plane and below the plane with another carbon, making the first pi bond, and the name of overlapping will be 2py overlapping. Now the unhybridized 2pz orbital will overlap parallelly or sideways with another carbon, making the second pi bond, and the name overlapping will be 2pz overlapping. So the first pi bond in the acetylene, due to the overlapping of the 2py, another pi bond with the overlapping with the 2pz and the 2pz. Now this is the complete hybrid orbital structure of the acetylene, which consists of the 3 sigma bond, 2 sigma bond present between the carbon and hydrogen, and the name of overlapping will be ssp overlapping. ssp overlapping, and the sigma bond that is formed between the carbon sp overlapping. The first pi bond formed due to the parallel or the sideways overlapping above the plane and below the plane of the 2py orbitals, and another pi bond will form due to the overlapping sideways or the parallel overlapping of 2pz above and below the plane. So as a result we will obtain total 3 sigma bond in acetylene and the 2 double bond in ethyne. And this is all about the structure. And if you will consider the carbon-carbon triple bond length, that is 1.20 angstrom. So this is the molecular hybrid orbital structure of acetylene in such way that it contains linear geometry with angle of 180 degree.